Hello, in this video we're going to look into solving equations that involved indices. In other words, in the process of doing the solution, we also need to use some of the indices rules. Well, let's go on. There are two examples we will look at as we move on. Throughout the solution, I will bring to our remembrance some of the indices rules as part of our revision. Okay, with that in mind, let's start. Okay, the first example, solve 4 to the power 3x equals 2 to the power of x plus 1. Okay, so the questions has been copied down for us. As mentioned, okay, indices rules are definitely involved here. And now I want to give us a helpful tips in solving equations involving indices is always find the way to change or rearrange both sides to have same base. All right, so this is the key to solving. Therefore, now with that in mind, on the left hand side, the base is 4. The right hand side, the base is 2. Okay, we recall what are the base that 4 can be changed in order to share the same base as 2. Okay, let's put in the color. This is the base 4 and we're going to look at that with the target to change them so that they can have the base 2. Yes, if you're already very familiar with this, let's go on. So the 4, we can change them into 2 square. All right. So from 4, we can rearrange them into 2 square. Then what about the 3x? In order to help our eyesight, let's use a set of brackets to keep our eyesight um, easier to differentiate. All right. And then on the right hand side, there's nothing much we need to do. So what we'll do is you just copy and paste it down here. All right. Nothing much you can do. All right. So now the next things. Now we see that we already got the same base. You are progressing well. Now you got the same base. No, I don't want this to be in gray. So now the next things, you will see that there is power and again to another power of 3x. And as our revision for indices rule, what does indices rule tells us? When we have, let's say, 8 to the power of 2, if there is a power of 3 out there, so when there are two indices powering each other. So what we will do is we just take the index, multiply them together. Okay, so we are going to use this rule over here. Okay, that will make it this way. 2, this power of 2. Now what we're going to do is we're going to multiply with the 3x. See that? Okay. And again, the right hand side, nothing much we need to do. So we're just going to copy and paste it there. Okay. So now you notice that both of them have the same basis. And so this is the convenience that we see. You got base 2 and I also got base 2. So in other words, from this stage, we no longer have to compare the base, right? So now we are going to compare only with the equal sign in the center, left hand side, 2 times 3x to get us, so let me, okay, I do not want to skip the step. I'm going to copy one more time. Then the right hand side will have x plus 1. Okay, and then so then the 2 times 3, we know that there's going to be 6x equals x plus 1. As of now, I'm sure you see that from us kind of like complicated indices, questions now has become a simple linear equation. Yes, you're going to minus x on both sides in order for us to get 6x minus x over here. Then here you have only 1. So you're going to have 5x equals to 1. Divide 5 both sides. And here we were only left with a x. And here we got 1 over 5. Okay, so that's the final answer. If you want to make it into decimal, or you can just put it here. So 0.2. And that's it. That's the solution. Okay, so this is for the first example. Let's move on to the second example. Using the same idea, keeping the I towards same base, all right, the same base. So again, what we're going to work on, okay, let's focus on the 3, the 9, and how about let's put in 27. Can both of these numbers share the same smallest as their base? Smallest number as the base. Okay, let's take a look at this is the blue color. It's for the 27. Let's put in green for this. Okay, so what can we do with the 9? Okay, we know that 3 squared equals to 9. So let's arrange that 9 into the form of 3 squared. And then the indices, what do we do? Just copy it down, right? No, nothing much, just copy it down. So now your number 9 has been rearranged into 3 square. Now the same way that 27, what base of 3 to the power of what to get 27? And if you are familiar with the list of cubes, then you know that 3 cubes gives us 27. So we're going to put there 3 cubes. And this is our 27. And now the original index, we just paste it here. Okay, that's all. Then now we're going to use the rules that we used just now. So the power upon power, so we're going to multiply them. So that will give us 3, 2 multiply 3x plus 4. And the right hand side, you got 3 to the multiply of 4x plus 3. Okay, so let's compare both of them. This got base 3, that side also got base 3, but all of them has been rearranged into similar format. Okay, and then so you notice you no longer have to compare the 3, so you can remove it. Okay, so you can take them out. Then now you compare only the 2 indices. Just to show the effect, hopefully that helps you to remember. So now you only compare both indices. Okay, therefore now, okay, follows the solutions will be just simply expand the brackets, collect like terms, and solve for x. Okay, let's start this. 2 times 3, you got 6x. Then plus 8 equals, this side 3 times 4, you got 12x plus 9. Then, okay, I'm going to put the 12. I want to keep the x as positive, so I minus the 6 over. So I'm going to get minus 6x. Then, now I'm going to minus the 9, minus the 9 here, and that I'm going to get 8 minus 9. Okay, then you got so here you got 6, and here you got negative 1. So 6 equals to negative 1 over 6. And that's it. Okay, that's the solution for the second examples. Okay, so as a recap, before we end this video, when you encounter the questions involve indices, the first thing you need to remember, try to rearrange them so that both sides of the equal sign shares the same smallest number as their base. Okay, so the first example, we reduce it to 2. Both of them, we reduce them to 2. and then we no longer have to compare them. All right, and then for the second example, from 9 and 27, we reduce them to base 3. Okay, and again, we achieve the same effect and convenience that we no longer have to compare the base. And now, for both of the examples, we just compare their indices, and that leads us to either expanding brackets if there is necessary, and collect like terms, collect all the unknowns to the left hand side, and then just apply the inverse operations, and the solutions will come out confidently, and to you it will mean full mark. Okay, so that's all for today, and then so till the next video, take care, bye bye.